Good morning everyone, and we are going to discuss in this video the definite integration. And we have the following objectives. Number 1, determine the fundamental theorem of calculus. Number 2, solve functions involving definite integration. And last is to calculate areas under the graph of a function bounded by limits. So this is the fundamental theorem of calculus, which it states that if f of x is continuous on the closed interval a and b, and if uppercase f of x is the indefinite integral of the function, then we have the limit of the summation of the function of z sub I change in x sub I from I is equal to 1 going to n as n approaches infinity is equal to the integral of the function from A to B, which is equivalent to f of B minus f of A. In other words, the fundamental theorem states that given an integral function f of x, kindly take note of the f of x here. F of x here is a lowercase, and we can compute the definite integral of this function by finding its indefinite integral denoted by uppercase f of x, and secondly by evaluating this indefinite integral at b as a function of b and at a, and finally subtracting it. So meaning to say, we have four different steps that we are going to perform in order for us to apply the fundamental theorem of calculus. The first one is we have to find the indefinite integration or indefinite integral of the given function, just like what we are doing when we solve for the indefinite integral of different functions, just like what we had studied before. Then that's the first one. The second one is we have to evaluate f of x at b, meaning after we get the indefinite integration or the indefinite integral, we are going to substitute the upper. So we are going to use the upper boundary or upper interval in the closed interval, the upper limit. And then you are going to evaluate again the indefinite integration using a, where a is the lower limit. And finally, we will subtract. So that's the fourth step, or step 4. Let's try to have an example. Suppose we are going to evaluate x squared dx, or the integral of this particular function from 1 going to 2. So let's perform our steps. Basically, we have 4 steps. The first one is to solve the indefinite integral of x squared, and with that we are going to get the indefinite integral of x squared. And using our knowledge of integration, we have x cubed divided by 3 plus c, and this is the first step. Next is we are going to perform the second step, which is after getting the integral or indefinite integral of the function, we are going to substitute the b. B here is, if we're going to analyze, b here is equal to 2. So b is equal to 2, and then a is equal to 1. So we have to know, or we have to determine the values of a and b. And usually a is the lower limit and b is the upper limit. Then let's perform. So we have b x cubed over 3 plus c. Then this is equivalent to 2 cubed over 3 plus c. And then let's perform the third step, which is for a. So we have to substitute a. We have 1 cubed over 3 plus c. And finally, the fourth step, we are going to subtract 2 cube over 3 plus c minus 1 cube over 3 plus c. So let's use parentheses because it will really make us be confused. Let's use minus. And then let's evaluate. If we're going to continue the process, so this will be our answer. So the last step would be evaluating all of this. So we have 248 over 3 plus c minus 1 over 3 minus c. And then you will notice that we will be canceling c. So the final answer now becomes 8 thirds minus 1 third, which is 7 thirds. So which is 7 thirds. And this time we are no longer putting plus c because as you notice, we cancel the plus c. So that's the basic of evaluating the definite integral of the given function. So let's continue with example number 2. In this example, we have the integral of x cubed minus 2x from negative 2 going to positive 2. Let's perform our 4 steps once more. Step 1 is to integrate the given function. So to integrate x cubed minus 2x, we have x to the 4th power divided by the new exponent minus 2x squared divided by the new exponent. And based on our previous example, we will no longer put plus c, the constant of integration, because eventually we will cancel c. So it would be better if we're not going to put plus c here anymore. And then this is now the integral, or if we're still going to evaluate this, finally we will arrive at x to the 4th over 4 minus x squared. And then step 2 is to substitute based on our given example. So once again, we will notice that b is equal to 2 and a is equal to negative 2. And if we're going to substitute b to all the x values of our integrated function, we have, so x to the 4th power divided by 4 minus x squared. We will have 2 to the 4th power over 4 minus 2 squared. And we have 4, so 2, 4, 8, 16 divided by 4, that is 4 minus 2 squared is 4, and this is equivalent to 0. And then let's go to the third step, and this one, let's substitute negative 2. So we have x to the 4th power over 4 minus x squared, and then substitute negative 2. So we have negative 2 to the 4th power over 4 minus negative 2 to the 2nd power. Then we will get 16 divided by 4, that is 4 minus 4 is 0. And then our last step is to subtract the value obtained from the second step from the third step. So we have 0 minus 0 is 0. Therefore, the integral of x cubed minus 2x dx from negative 2 to positive 2 is equivalent to 0. Now let's proceed with example number 3, and this time we will be evaluating x squared plus 4 from negative 1 to positive 1. Still, we are going to perform our four steps as provided to us by the fundamental theorem of calculus. So let's go to the step 1, and this time we are going to integrate x squared plus 4. We will have x cubed divided by the new exponent, which is 3 plus 4x. And this is now our answer for step 1. And then as you notice, um, we no longer put plus c because we already discussed that on the first example. So step 2 is to substitute. We see that b is equal to 1 and a is equal to -1. So for step 2, we substitute +1. And then we have x cubed over 3 plus 4x. Then substituting the value of 1, we have 1 cubed over 3 plus 4 times 1, which is equal to 1/3 plus 4, which is also equivalent to 13 over 3. So this is our answer for step 2, 13 over 3. Let's go to step 3 for -1. So we continue x cubed over 3 plus 4x, and then substitute -1 to all x values. We have -1 cubed over 3 plus 4 times -1. And then if we're going to continue with the process, we will have -1/3 minus 12 over 3, and we have -13 over 3. So this is our answer for the third step. And let's go to the fourth step. Let's go to the fourth step, and this time we subtract what we obtain in step 2 by the answer we obtain in step 3. So we have 13 over 3 minus -13 over 3, that is equivalent to 26 over 3. And this is now our final answer. Now let's continue with example number 4, and this time we are going to find the area under the curve y is equal to x squared from x is equal to 1 going to x is equal to 3. So this example is different from the first 3 examples that we had, and because of that, we should have to visualize first what it looks like. We have the following um, representation. We have 1, 2, 3, 4. So we have, let's say this is 2, 4, 6, 8. 2, 4, 6, 8. So 1, 2, 3, and 4. This is the x, and then this is the y. So if we have 1, that is 1, 1 here. This is the location of the point. And then if we have 2, we have 4. If we have 3, we have 9. So basically, if we have 0, 0, then we connect them. So this is what it looks like. Now, if we consider from x is equal to 1 going to 3, so this one, this portion, we are going to solve for the area of this shaded portion. We shade this portion. So from 1 to 3. So that is what is meant by the given problem. Now, how to calculate the area of the shaded portion of the graph under y is equal to x squared. So from here, we just have to follow our 4 steps that we obtained from the fundamental theorem of calculus. So let's start with step 1. So we have the integral of x squared. Then we have x cubed over 3. And then step 2, from the upper limit, which is 3. So we have x cubed over 3, then substitute 3, so we have 3 cubed over 3, that is equivalent to 27 divided by 3, that is equivalent to 9. And then continue with step 3. So step 3, we have the same problem, x cubed over 3, and then we substitute 1, so we have 1 cube, and then we have 1/3. And then finally, we subtract. So 9 minus 1/3, that is equivalent to 26 over 3 over 3. And this is now the final answer. But since we are looking for the area, and area is expressed in terms of units squared or square units, then we have to put the units, or units, squared units, and this is our final answer. And let's continue with example number 5, and this time let's find the area under the curve of the function 2x cubed minus 6x between x is equal to -1 and x is equal to 0. So what we're going to do here is to use our 4 steps. Step 1 is to integrate the given function to x cubed minus 6x dx, that is equivalent to 2x to the fourth over 4 minus 6x squared divided by 2. Then we have x to the fourth over 2 minus 3x squared. For step 2, let's substitute. Since x is equal to -1 and 0, so we have b is equal to 0 and a is equal to -1. So substituting the value of 0 to all x, so we have 0 raised to the fourth power over 2 minus 3 times 0 squared, and then eventually it gives us 0 value. So this is the answer for step 2. Step 3, we have for -1, so we have -1 to the fourth power over 2 minus 3 times -1 squared. So we have 1/2 minus 3, and this is equivalent to -5 over 2. This is the answer for the third step, and last step is to subtract. So 0 minus -5 over 2, -5 over 2, and that is equivalent to 5 over 2, or simply 2.5. And let's put the unit is square units because we are looking for the area. And this is now our final answer. This is the end of our lecture for an introduction to definite integration.